Hi, this is Srikanth, Assistant Professor of EEE Department. In this session, I'm going to discuss some problems on superposition theorem. Superposition theorem states that in any linear, bilateral, planar circuit which consists of two or more sources, the response in any element is equals to algebraic sum of responses caused by individual sources acting alone by making other sources as non-operative. Non-operative means voltage source replaced with short circuit and current source replaced with open circuit. So for that, here it is asked to find the current flowing through 20 ohms using the superposition theorem. So for calculating current flowing through 20 ohms, first we need to take the consideration of first with 20 volt source is acting and then 4 ampere source is acting. So here when 20 volt source is acting, when 20 volt source is acting, this 4 amperes will be open circuited. When 4 amperes is open circuited, the circuit will become like this. So in order to calculate the current flowing through 20 ohms, we are going with the nodal method by considering this node voltage as V1. Now we are applying KCL at node 1. KCL at node 1. So here, whenever we are applying the KCL at node 1, all the currents are leaving from the junction. That is our assumption. Here, when we are writing the KCL at node 1, we are considering that all the currents are leaving from the junction. This is the assumption we are considering. So here the current flowing in this particular direction in the 5 ohm resistance is V1 minus 20 because we are assuming that this voltage is at higher potential. So V1 minus 20 by 5. V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus V1 by this 10 ohms and 20 ohms are connected in series. V1 by 10 plus 20, that is equals to 0. Here we are going to get 6V1 minus 120 plus 3V1 plus V1 by 30 is equals to 0. Here 10 into V1 is equals to 120 where V1 is equals to 12 volts. Now the current flowing through the 20 ohms because of this 20 volt source is I1 is equals to V1 by 10 plus 20, which is equals to the V1 value is 12 volts by 30, which is equals to 0.4 amperes. So the current flowing through 20 ohm resistance due to 20 volt source is acting is 0.4 amperes. Now we got the current because of 20 volt source. Now we need to calculate current flowing through 20 ohms because of 4 ampere current source. So for that, the voltage source is replaced with short circuit and current source will be acting as it is. Here 20 volts will be replaced with short circuit. So here when 20 volts is short circuited, this is the 4 amperes current source. In the above circuit, the resistors 5 ohms and 10 ohms are parallel to each other. Here, in order to calculate the current flowing through this 20 ohms, we need to calculate the equivalent resistance between this A and B terminals. And for calculating the equivalent resistance between A and B terminals, this 5 ohms and 10 ohms are connected in parallel, that is in series with 10 ohms. So RAB is equals to 10 plus 5 into 10 by 5 plus 10, which is equals to 40 by 3 ohms. Now the simplified circuit is as follows. That is only 40 by 3, which is in parallel with 20 ohms and 4 ampere current source. Now these two resistors are connected in parallel. When these two resistors are connected in parallel, the current division will takes place. So here, this is the current I2. Let us consider I2 is equals to Is into opposite resistance R1 by R1 plus R2, which is equals to Is value 4 into opposite resistance is 40 by 3 whole divided by 20 plus 40 by 3, where I2 is equals to 1.6 amperes. Therefore, the current flowing through the circuit when only 4 ampere current source is 1.6 amperes. Now we got the current flowing through the circuit when only with 4 amperes current source is 1.6 amperes. Now, as per the statement of superposition theorem, the total current flowing through any element is equals to sum of currents because of individual sources. That is, I is equals to I1 plus I2. Substituting the values of I1 and I2 in the above equation, we get I is equals to 0.4 plus 1.6, which is equals to 2 amperes. Therefore, the current flowing through the resistor is 2 amperes. Now we will go the next problem. Find the current flowing through 1 ohm resistor by using superposition theorem. Now we need to calculate what is the current flowing through 1 ohm resistance. So first let us take any one source as acting and the other source is non-operative. So here first we are considering the 130 volt source is acting and 110 volt source is non-operating. That is nothing but 110 volts is replaced with the short circuit. So here this is the 130 volts, 0.2 ohms, 0.2 ohms, 0.2 ohms and 1 ohm. Now for calculating the current flowing through 1 ohm, here let us consider this current as I1 dash. So for calculating the I1 dash, we are going to apply the mesh analysis. So by considering 130 volts voltage source, here we are taking the two currents, two meshes are there. In these two meshes, this is the I1 and this is the I2. So when we are writing KVL for loop 1, we are going to assume that I1 has higher magnitude. So here the drops are considered negative and the voltage is considered as positive, that is minus 0.2 I1 and minus 0.2 into I1 minus I2 plus 130, which is equals to 0, which is equals to minus 0.4 I1 plus 0.2 I2 equals to minus 130. This is our equation number 1. Now minus I1, this is the current which is flowing through this. I2 is, this is not minus I1, this is I2. Minus I2 minus 0.2 into I2 minus I1, because when we are writing KVL for loop 2, we are assuming that I2 has higher magnitude. I2 minus I1 minus 0.2 into I2, which is equals to 0. From this we'll get 0.2 into I1 minus 1.4 into I2 is equals to 0, where I1 is equals to 350 amperes, I2 is equals to 50 amperes. And this is the I1 dash which is flowing in the downward direction, that value is 50 amperes. Now we are considering that 110 volts source is only acting by making 130 volts as short circuit. Consider when 110 volts is acting, minus 0.2 I1 minus 0.2 into I1 minus I2 minus 110, which is equals to 0. From this minus 0.4 into I1 plus 0.2 into I2 equals to 110, where minus I2 plus 110 minus 0.2 into I2 minus I1 minus 0.2 into I2, which is equals to 0. And here 0.2 I1 minus 1.4 I2 equals to minus 110. Now we got the another set of equations. Now when we solve these two equations, I1 value is minus 253.84 and I2 value is 42.3076. Here I1 double dash is equals to 42.3076. So current flowing through 1 ohm is equals to, according to superposition theorem, these two currents will be added. I1 dash 1 ohm plus I1 double dash 1 ohm, which is equals to 50 plus 42.3076, which is equals to 92.3076. Now find the current flowing through 5 ohms. Here we need to calculate what is the current flowing through 5 ohms. For that, first we are making the 4 volts as short circuit. When 4 volts is short circuit, our circuit will be like this, and we are going to apply the mesh analysis by considering I1 and I2 are the currents. That is equals to, when we apply KVL in loop 1, KVL in loop 1, 2 minus 0.1 I1 minus 10 I1 minus 5 into I1 minus I2, because current I2 is flowing in the opposite direction. That is equals to 15 I1 plus 5 I2 equals to minus 2. This is our equation number 1. Now for writing the KVL in loop 2, KVL in loop 2, that is minus 20 I1 minus 0.2 I2 minus 5 into I2 minus I1, which is equals to 0. That is 5 I1 minus 25.2 I2 equals to 0. This is our equation number 2. By solving equations 1 and 2, by solving equations 1 and 2, we are going to get the I1 value as 0.1417 amperes and I2 value as 0.020812 amperes. Now I phi dash is equals to I1 minus I2, which is equals to 0.1417 minus 0.02812, that is 0.1158 amperes. Now let us go with by considering the 4 volt source is acting by making 2 volt source as inoperative. That is nothing but short circuit. 2 volt source is short circuited here. Here we are going to consider that only 4 volt source is acting. So when we consider 4 volt source, by applying KVL in loop 1, KVL in loop 1, minus 0.1 I1 minus 10 I1 minus 5 into I1 minus I2, which is equals to 0. That is minus 15.1 into I1 plus 5 I2 is equals to 0. This is our equation number 3. And 20 I2 minus 0.2 I2 minus 4 minus 5 into I2 minus I1, which is equals to 0. Where 5I1 minus 25.I2 equals to 4. Now if we solve these two equations, equation 3 and 4, we will get the I1 value as minus 0.05685 amperes and I2 value is minus 0.1698 amperes. Now I phi double dash is equals to I2 minus I1, that is equals to 0.1130 amperes in the downward direction. Now here I phi ohms is equals to I phi dash plus I phi double dash, which is equals to 0.2288 amperes. The next problem is determine the current through 1 ohm resistance. This is the current which we need to calculate in this particular direction. That is, in order to calculate that current, first we are considering that only 10 volt source is acting. So when 10 volt source is acting, 8 volts and 6 volts are short circuited. When these two are short circuited, only 2 loops circuit we are going to get. Here when we apply, only a 10 volt source is acting by applying KVL in loop 1. KVL in loop 1, that is equals to minus 2 into I1 minus I2 minus 2I1 is equals to 0. That is equals to minus 4I1 plus 2I2 equals to 0. Now for applying, now we are going to apply KVL in loop 2, that is minus 10 minus 2 into I2 minus I1 minus I2, which is equals to 0. Where 2I1 minus 3I2 is equals to 10, where I1 is equals to minus 2.5 amperes and I2 is equals to minus 5 amperes, where I1 dash is equals to minus 5 amperes, where I1 dash is nothing but this is the current I1 dash, that is same as the I2, so that is minus 5 amperes. Now we got I1 dash from left to right is minus 5 amperes. Now we are going to consider only 6 volt sources acting When the 6 volt source is acting, again we are going to apply the KVL in the loops, that is minus 2 into I1 minus 2 into I1 minus I2 minus 6 is equals to 0. That is minus 4 into I1 plus 2 I2 is equals to 6. Now when we go with by applying KVL in loop 2, KVL in loop 2, that is minus I2 into 1 plus 6 in plus 6 minus 2 into I2 minus I1, which is equals to 0. Here 2I1 minus 3I2, 2I1 minus 3I2 is equals to minus 6. Now I1 and I2 are, we got it as I1 as minus 0.75 amperes and I2 as 1.5 amperes. So I1 double dash is equals to 1.5 amperes from left to right. Now we got the current flowing through 1 ohm because of 6 volts voltage source. Now we'll go with by considering the 8 volts source. Now when we apply KVL in loop 1, that is equals to 8 minus 2 into I1 minus 2 into I1 minus I2 equals to 0. That is equals to minus 4I1 plus 2I2 equals to minus 8. This is our equation number 5. Now for writing the KVL in loop 2, that is minus 4I1 plus 2I2 equals to minus 8. This is our first equation corresponding to this particular circuit. Now KVL in loop 2, that is minus I2 minus 2 into I2 minus I1, which is equals to 0. That is 2I1 minus 3I2, which is equals to 0, where I1 is equals to 3 amperes and I2 is equals to 2 amperes. Now we got the I2 value as 2 amperes, that is I1 double dash is equals to 2 amperes from left to right. This is the I1 double dash. Now the total current is equals to I1 ohm is equals to I1 ohm dash plus I1 ohm double dash plus I1 ohm triple dash, which is equals to 2 plus 1.5 plus minus 5, which is equals to minus 1.5 amperes from left to right. When we consider from right to left, I1 ohm is equals to 1.5 amperes. This is the way we are going to calculate the current flowing through any particular resistance when we have 3 voltage sources. Now find the current flowing through 20 ohms. Now in order to find the current flowing through 20 ohms, first we are considering that this 10 volt source is acting, this 8 volts and 12 volts are short circuited. When this 12 volts is short circuited, short circuit is in parallel with 8 ohm resistance, that will become 0. So this complete path is going to be removed. So that is 10 volts, 10 ohms, 1 ohm, 20 ohms. So here for mesh 1, 10 into 10 minus 10 into I1 minus I2, that is equals to minus 10 I1 plus 10 I2 equals to minus 10. And for mesh 2, minus 10 into I2 minus 10 into I2 plus 10 into I1 minus I2 minus 20 I2, which is equals to 0. 10 I1 minus 31 I2 equals to 0. Now I1 is equals to 1.4761 amperes and I2 is equals to 0.4761 amperes. Where current flowing through 20 ohms is nothing but this is the current, that is I1 double dash, otherwise I 20 ohms dash. I 20 ohms dash. This is our current which is flowing through the 20 ohms because of 10 volts source. Now when we consider this 10 volts as short circuit, this 10 ohms will be replaced with a short circuit. So when it is of 8 volts, only 1 ohm and 20 ohms are connected in series. So I 20 ohms is equals to minus 8 divided by 21, which is equals to minus 0.3809. This is I 20 ohms double dash. Now we are taking the 12 volt source is acting. When 12 volt source is acting, the remaining sources will be replaced with short circuit. So if we apply KVL, this is the I1, let us consider, that is minus 12 minus 8 into I1 plus 8 I2 equals to 0, because 8 into I1 minus I2. So which is equals to minus 8 I1 plus 8 I2, which is equals to 12. And then let us apply the KVL in the other loop, that is minus 1 into I2 minus 8 into I2 plus 8 into I1 minus 20 I2, which is equals to 0. Here 8 I1 minus 29 I2 is equals to 0, where I1 is equals to minus 2.07 and I2 is equals to minus 0.57. Now I2 is nothing but the current flowing through this 20 ohms. So I triple dash is equals to minus 0.5714. Now according to our superposition theorem, I 20 ohms is equals to I dash plus I double dash plus I triple dash. If we add, the current will be going in the downward direction, that is 0.4761 minus 0.3809 minus 0.5714. So I 20 ohms is equals to minus 0.4762 in the downward direction. But when we take in the upward direction, this value will be positive. I 20 ohms is equals to 0.4762 in the upward direction. Now find the current through 3 ohm resistance using superposition theorem. This is the current which we require. Now when we consider only 20 volt source is acting, the other source is not acting. When the other source is not acting, here we can calculate, first we can calculate the total current, then after we can calculate the I1 value, current flowing through 3 ohms. So here for calculating current, we are taking AB terminals. So RAB is equals to 5 plus 3 into 6 by 6 plus 3, which is equals to 5 plus 2, 7 ohms. This is the RAB value. Now I total is equals to 20 by 7, which is equals to 2.857. This is our total current, and this total current is divided into two. That is, these two are connected in parallel, 3 ohms and 6 ohms. When these two are connected in parallel, the current flowing through 3 ohms, I1, let us consider I1 is equals to IT into opposite resistance is 6 ohms by 6 plus 3. That is equals to 1.904 amperes. Now, because of 40 volts, what is the current flowing through this? Now, in the same way, here we need to consider the A and B terminals. So, RAB is equals to 6 plus 3 into 5 by 5 plus 3, which is equals to 6 plus 3 5s are 15 by 8, 7.875 ohms. Now IT is equals to 40 by 7.875, which is equals to 5.079 amperes. This is the total current which we got, and I2 is equals to IT into opposite resistance. Here the opposite resistance is 5 ohms divided by 5 plus 3, which is equals to 5.079 into 0.625, which is equals to 3.174. Now we got the I1 and I2, where I is equals to I1 plus I2. That is equals to I1 value, we got it as 1.904 plus 3.174, which is equals to 5.078 amperes. This is our current in the 3 ohm resistance. In this session, we have discussed different problems by using superposition theorem have been solved. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.